Hello, everyone, and welcome back. So we're looking at polynomial operations, and we're talking about multiplying a polynomial by a monomial. Now, we've done a video where we've introduced everything you need to know about polynomials, monomials. So if you feel like you're starting this video and you're not really aware of what a polynomial is, please go and watch that video first. So let's have a look at what we need to do when we're multiplying a polynomial by a monomial. Now, the way we do this is that we need to understand that if I have something like this, so if I have, let's say 2 and then like 2 and then I have 3 like this, right? Now we said before that if I ever have numbers written like this, so 2 and then a bracket, this means that I'm multiplying 2 by 3, right? And if I have 2x, then this means that I'm multiplying 2 by x, right? And let's look at another example. So if I have x and y, then this means that I'm multiplying these two variables, x multiplied by y. And remember, multiplication could either be an x like that, or it could be a big dot in between them. Okay. Now, one last thing here. If I ever say I'm multiplying x by x, I need you to remember your exponent laws where over here I would add these two since it's a power of the same base. Then I add their exponents, so it become x to the power of 2. And if I change this to 2, for instance, then I'd have just, so I'm going x, right? So imagine it looked like this. It's x multiplied by x squared. Again, I'm seeing that they're the same base, so I go, oh, add these exponents, so it become x to the power of 3, okay? So now that we've done this review, let's have a look at what the distributive property is. So the distributive property here states that if I have a monomial as such, so that's one term, multiplied by a polynomial, so that's two terms over here, right? So multiplying something that is more than one term by one term, what I do here is I use something called the distributive property. Now, do you see how when you did 2 times 3, all you did was take this 2 and multiply it by the 3. Now, if I ever have a 2 and then I get 3 plus x, for instance, so I have a polynomial inside. So I have this monomial multiplied by this polynomial, okay? Now, the only difference here is that instead of multiplying it by the 3 only, I multiply it by the x as well. So I multiply it by every term inside, right? So what I'm saying is I'm distributing this 2 to everything inside, okay? So I'll go 2 times 3 plus the sign stays in between them. So 2 times 3 plus 2 times x, okay? And then we can simplify this further. We can say 2 times 3 is 6 plus 2 times x is 2x, okay? So when I multiplied this monomial with this polynomial, I ended up with another polynomial, okay? So what I want us to notice here is that I distributed this to both of them, and I kept the sign in between them just like it was. So I said, oh, a multiplied by b, kept the sign, and then a multiplied by c. And whether I put the 2 in front or at the back, so if I say, if I switch this up a little and I say, you know what if I go 3 plus x multiplied by 2, and I don't even need to write it in a bracket. I just write it beside it like that, or in a bracket, okay? Then again, this means the same thing. I need to distribute it to both of them, okay? So this becomes 2 times 3 plus 2 times x, okay? Which again would be 6 plus 2x, okay? So this is all the second part is saying. It's saying that even if you put it on the other side and you distribute like this, right? You distribute in this way so that you have VA plus CA or AB. So if you distribute backwards, right? So let's say you distribute backwards, you say, you know what, just like I did with the 2, I'm going to distribute the 2 in this way. Then you get the same thing, you get AB plus AC. And I want you to keep something in mind. Whether I flip this 2 and 3, right? So let's say I take this 2 and 3 and I say, oh, this is the same as saying 3 times 2. Well, that is true, right? because we know that multiplication is commutative. That means that whether I flip it, right, whether I say 3 times 2 or 2 times 3, they both mean the same thing. So that's what's going on over here, where I get either this or this. If I flip the variables, it doesn't change its value, okay? So this is how you multiply a polynomial by a monomial. You just use the distributive property, and I'll do one quick example before we end this video. If I have, let's say, 3x, so this is my monomial, okay? And I multiply this by 2x squared plus 3 plus 5x, okay? Now what's going on here? Again, what I need to do is I need to consider, oh, okay, it looks like I have a monomial multiplied by a polynomial. Let me just write it on the side here. So this is my example, and this is my polynomial, okay? So over here, I have my monomial, I have my polynomial, and all I need to do is use distributive property. I need to say I need to distribute this 3x, the entire 3x, multiplied by 2x squared, as well as multiplied by 3, as well as multiplied by 5x. So what you notice here is that whatever is sitting outside the bracket goes to every single thing inside the bracket, okay? So then that means that I'm going to have 3x multiplied by 2x squared. That's going to be, let's write it out first. So this is going to be 3x multiplied by 2x squared plus 3x multiplied by 3 plus 3x. Ooh, and even if I want you to notice that even if I change this sign, this carries with me. Okay, so it literally just shows up in the place of when I'm multiplying by the 5. So minus 3x multiplied by 5x. Okay, all right. So what are we noticing over here? Or you can even think of it like this. It's okay. This is good for now. So now that we're trying to simplify this, what I notice is that just like I did in this step over here where I said, oh, if they have the same base, x and x, then I add their exponents. That's what's happening over here. Anytime I have a coefficient like 2x multiplied by 3x, for instance, then what I do is I multiply the coefficients together. So I go 2 times 3, that's 6. And then I multiply the variables together, so that's x squared. Okay. And same thing with same thing with adding. I add the coefficients and then the x just stays there. So over here, when I'm multiplying this, then I'm saying, oh, 3 times 2, that's 6. X times x squared. Now, notice what happens when I multiply x by x squared. They have the same base, x. Now I need to add their exponents. It's exactly the one that we had over here. So then I get x to the power of 3, okay? So I get 6x to the power of 3 plus, over here there is no variable, so I just need to multiply the coefficients and the coefficient with the constant over here. So I go 3 times 3, that's 9, and then x times, technically, like multiplied by 1, right? So x and then just x. Okay, so I go just multiply these and then carry the x with it. So 9x. And then over here I have negative 3 multiplied by 5. So that's negative 15. And then x multiplied by x, well, x multiplied by x, same base, I add their exponents, so it becomes x squared. Okay, so this sums up multiplying a polynomial by a monomial, everyone. Just make sure that when you are using the distributive property, you are distributing everything outside, this entire thing, to everything inside. That's the first one. And then, I go take this and multiply it by this one. And I continue doing this to get every term, okay? All right, everyone, that's it for this question. I hope that helped. Sorry, that's it for the section. I'll see you in the next video. Bye.